Hey, this is Presh Talwalkar. In this video, I will share 3 different problems about circles and rectangles. Problem 1 from an Australian math competition. A coin rolls on the interior of a square along its sides without slipping. After the coin has returned to its starting position, the coin has made one whole revolution. If the coin's radius is equal to 1, what is the side length of the square equal to? Problem 2. This comes from a Math Kangaroo competition. A rectangle is divided by 2 circles. The top side of the rectangle is divided into 3 segments, as is the bottom side. The 3 segments on the top side have lengths of 8, 26, and 22. On the bottom side, 2 lengths are equal to 12 and 24. What is the third length equal to? Problem 3. This is from Twitter at cshear41. Here's a circle, and here are 4 squares. 3 of the areas are known as 16, 25, and 100. What is the area of the circle? Pause the video if you'd like to give these problems a try. And when you're ready, keep watching to learn how to solve these problems. So let's solve problem 1. Now in the lower left corner, we can construct a square whose side length is equal to the radius of the coin. Now let the coin roll along the bottom side of the square. On the bottom right corner, we can construct a congruent square where its side length is also equal to r. Let the coin roll on the right side of the square, and we can construct another square with a side length equal to r. Let the coin roll on the top side, and we construct a 4th square with a side length equal to r. The coin then rolls on the left side of the square and returns to its starting position with one whole revolution. Since it has made one whole revolution, we know that on each side it has made a quarter turn. So exactly 1/4 of the circumference is spanned by this distance between the 2 squares. So the length between these 2 squares is equal to the circumference of the coin divided by 4, which equals 2 pi r divided by 4, and that equals pi r divided by 2. So the entire square side length is equal to r plus pi r over 2. Factoring out the r gives r multiplied by 2 plus pi over 2. In this problem, r is equal to 1, which means the side of the square is equal to 2 plus pi over 2. And that's the answer to problem 1. Now let's solve problem 2. So first, let's construct a rectangle whose side length is equal to the smaller chord's length. Then construct a diameter of the circle. And notice we have a symmetry. Everything to the left side of this diameter is the same as everything to the right side. They are congruent. To be more precise, the diameter is the perpendicular bisector of the upper and lower chord. So on the upper chord, this left side is exactly equal to this right side. On the bottom chord, the left side is exactly equal to the right side. So if we take the length of half the upper chord minus half the lower chord, we end up with this length on the left side, and it will exactly be the same length on the right side. So if we construct this rectangle on the left side of the circle, we know that one of its lengths will be equal to 12 minus 8, which equals 4. By symmetry, we can exactly translate this over to the right side of the circle. This length will also be equal to 4. So on the bottom side, we can bring down this 24. So we have a length of 4, and the remaining length will be 24 minus 4, which equals 20. We'll do the same construction in the other circle. Construct a rectangle whose one side length is equal to the smaller chord of the circle. Then we divide the circle right down the middle, so we have symmetry on both sides. We construct this rectangle, and we can see that one side length is equal to 26 minus 20, which equals 6. We bring this rectangle over to the other side of the circle, and now let's say the missing length is equal to x. So we have 6 plus x is equal to 22, and that means x is equal to 16. And that's the answer to problem 2. So now let's solve problem 3. The first thing we'll do is we'll calculate the side lengths of each square. So the square with area of 16 will have a side length that's equal to 4. The square with area of 100 will have a side length equal to 10. The square with area 25 will have a side length equal to 5. Finally, let the rest of this chord have a side length that's equal to x. Let's focus just on these two chords of the circle. By the chord power theorem, we have 5 multiplied by x is equal to 4 multiplied by 10. So 5x is equal to 40, and x is equal to 8. Let's now do another construction. Along this chord, let's go up 4 units and then construct a parallel chord that's congruent to the other horizontal chord. The remaining distance will be 10 minus 4, which is equal to 6. We will then complete a rectangle. This length will also be equal to 6. Now, since we have a rectangle, we have a right angle here, and that means these two chords will subtend the diameter of the circle. So this chord will be a diameter of the circle, and its length will be equal to 2r. We now have a right triangle where the hypotenuse is equal to 2r, one leg is equal to 6, and the other leg is equal to 8 plus 5, which equals 13. We'll just focus on this right triangle. We have 6 squared plus 13 squared is equal to the square of 2r. This means 205 is equal to 4r squared, and r squared is equal to 50.25. Multiplying both sides of the equation by pi gives that pi r squared, which is the circle's area, is equal to 50.25 pi. And that's the answer. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.